So good morning students. Now today we will do 2-3 numericals on the concept of electric potential. One numerical I have already given to you in the previous lecture. So let's come to the statement first. If 100 joule of work has to be done in moving an electric charge of 4 coulomb from a place where potential is minus 10 volt to another place where potential is V volt. Find the value of V. See, first of all, we have to understand how to proceed for numerical. What is given here? 100 joule work. So work is given to be 100 joule. Second thing, what has been given here? Charge. Charge is given to be 4 coulomb. And first potential, we are taking the two potential at V1 is given to be minus 10 volt. And final potential which we have to calculate, that is given to be V. We have to calculate V. So now on the basis of the given data, we can take it as that V2 minus V1, as we have to find the potential V. This will be equal to work done per unit charge. So V2 is V here, minus V1 is minus 10 volt, work done is 100 joule and charge is 4. So it is V plus 10, this is 25. V will be 25 minus 10, that will be 15 volt. So if 100 joule of work has to be done in moving a charge of 4 coulomb from a place where potential is minus 10 volt to another place where potential is V. Find the value of this V. So basic definition, basic concept that you have to apply the concept of potential difference. That means V2 minus V1 will be equal to work done per unit charge. This is its key point. If this formula is clear, then you can easily solve it. Now V2, that is value you have to calculate. V1, that is initial value given. Work done 100, charge 4. So you have taken V plus 10 equal to 25. So V will be 15 volt. This will be the answer. Now after this numerical, let me take another numerical. This is very, very important. Now first of all, let me understand the statement. 27 drops of same size are charged at 220 volt each. They combine to form a bigger drop. Calculate the potential of bigger drop. See, 27 drops of same size have been given. The number of drops is 27. These are, each drop is charged to potential 220 volts. First of all, we will collect data that has been given in the numerical. They combine to form a bigger drop. Find the potential of bigger drop. We have to find the potential of bigger drop, that is V dash. So as per the numerical, we have such kind of small drops are there. They are combining to form big drop. Let capital R is the radius of big drop. Capital R is the radius of big drop and small r is the radius of small drop. So now whatever volume of small drop is there, that is combining to form big drop. So you can take that as V dash. Volume of bigger drop will be 27 times volume of small drop. So what is the volume of big drop? Spherical shape. This will have formula 4 by 3 pi r cube. And this will be 27 into 4 by 3 pi r cube. So cancelling the common factor. This can be r cube, this can be 3 r cube. So this implies r will be equal to 3r. That means radius of bigger drop comes out to be 3 times the radius of small drop. Now we have to find potential of bigger drop. So first of all, what we will do, we will find the potential of each small drop. Let the potential of small drop. So what will be the formula? It has the formula 1 by 4 pi epsilon naught q upon r. From there we can calculate the value of charge. It will be 4 pi epsilon naught r into B. We have calculated the charge of each small drop. So we have total 27 drops. The total charge of 27 drops, this will be 27 into Q. So it will be 27 into 4 pi epsilon naught R into V. Now potential of big drop, that is V dash. Now apply the basic formula. Potential of big drop should be Q upon 4 pi epsilon naught R. So now substitute the value of this capital Q, total charge of all the 27 drops. So cancelling the common factors, this will come out to be 27 RV upon capital R. But something is left here, capital R. Yes, this is capital R, this is small r. So what we will do here, we will do just put the value of capital R equal to 3R. So you will substitute here. This will be 27 RV upon 3R. So it is 9V. Now potential of each drop was given to be 220. So here it will be 1980 volt. So potential comes out to be this one. So this is the numerical. Let me recapitulate all the steps. As big drop has been given, formed by combining 27 drops. So first of all, you have to apply. I am just marking the key points which you have to learn. Volume of bigger drop will be 27 times the small drop. What is the benefit of it? You will calculate relationship between the radii. Then find the potential of small drop by the formula Q, KQ by R. So from here you can calculate the value of Q. It is not required that you always substitute 1 by 4 pi epsilon naught, or you can also take it K because it will cancel out later on. Now total charge of 27 drops, 27 into Q. Then potential, that is Q upon 4 pi epsilon naught. So basic concept, but you have to remember that volume, that one thing you have to just pay attention, that you get confused with the symbols of potential and the volume. So you can take in this volume as V1 and V1 dash. This will be better if you will take, because otherwise we have taken the symbol for potential as V and for bigger drop as V dash. So take it for the volume as V1 dash and V1. This will not create any problem, just notation, you can change this also. So first of all you will compare the volume, second you have to learn the potentials. So this is the all step which you have to understand. So now next numerical we are taking, that is, it is important from the board point of view. This concept has been asked in board as well as from competitive point of view. Numerical statement is, understand the statement first. 3 concentric metallic shells A, B, C of radii A, B and C, small a, B, C, such that A is less than B, which is less than C, having surface charge densities plus sigma, minus sigma and plus sigma respectively. Find the potential of the 3 shells A, B and C. Independently you have to calculate the potential of A, B and C. If the shells A and C are at the same potential, obtain the relation between the radii A, B and C. See, the statement you have to understand, 3 shells have been given and their surface charge density has been given. Independently you have to find potential of the 3 shells, and if potential of A and C are equal, then establish relationship between the radii of the 3. So what should we do as per the statement? Let me take 3 concentric shells, metallic shells are there. This is A, this is B and this is C. Independent radius has been given, A, individual radii B and C. Their surface charge densities are, this is plus sigma for A, minus sigma for B and plus sigma for C. See, you can note down the diagram from there. Here surface charge densities has been given as per the shells. Now you have to find potential. So before calculating the potential, what should be the steps? Let me just take the key points what we have to do. As we have to calculate potential for A, B and C. So first of all, we require charge on each of the three shells. So first of all, charge on A. Charge density. Charge density is charge per unit area. So charge will be surface charge density into area. Being this is shells, this will have spherical shape, so it will be 4 pi a square, inner one, charge on A. Now charge on B, having surface charge density, this is minus sigma, so into 4 pi b square. Now charge on C, this will be plus sigma 4 pi c square. We have taken the charge of A, B and C. Now potential of A due to charge on A, charge on B, charge on C. Now this is a main point. This is a slight typical point which we have to understand. Potential at A due to charge on A. So you will take it as, this is QA. Let me take it, not it as VA, we can take it as V1 first, right? So charge on A, divide by 4 pi epsilon naught A. This A is in its suffix, not as a separate, or I am repeating it, QA upon 4 pi epsilon naught A. Same formula, this is nothing, no difference. Now QA, this is 4 pi A square sigma upon 4 pi epsilon naught A. So what will be the result? 4 pi will cancel, A will cancel, what will be left? Sigma A upon epsilon naught. This is first potential on A due to charge on itself. Now see, we have to calculate charge, we have calculated charge on B, but that is situated at larger distance, that is at radii B. Now you have to calculate potential of A due to charge on B. You have to calculate potential of A due to charge on B. This will be QB upon 4 pi epsilon naught. What will be the radii? It will be B. Charge is situated at this particular distance B. So that's why the distance will be B, because this charge cannot lie inside. This is a main point. Charge on this surface will reside only on this surface. It cannot contribute inner side. But potential, that can be at this particular distance. So here charge is minus sigma 4 pi b square upon 4 pi epsilon naught B. Potential of A due to charge on B, that will come out to be minus sigma 4 pi b square upon 4 pi epsilon naught B. This is the main point you have to understand. Don't get confused with it, because potential at A due to charge at B will be at distance B. Now 4 pi will cancel out. This will be minus sigma B upon epsilon naught. Now potential of A due to charge on C, this will be QC upon 4 pi epsilon naught C. So QC is, put the value 4 pi C square into sigma upon 4 pi epsilon naught C. Again, that charge on C shell is due to plus Q surface charge density. It is located at that point, but potential we can calculate at that point. So here this comes out to be C sigma upon epsilon naught. So here potential due to shell C will be this one, due to B will be this one, and A will be this one. So now potential at A will be V1 let it be V2, this will be V3, this will be V1 plus V2 plus V3. Add all three, sigma A by epsilon naught minus sigma B epsilon naught plus sigma C by epsilon naught. Take sigma by epsilon naught common, A minus B plus C. Slight difficult concept we are applying here. We are getting one important conceptual concept, that when we have to calculate potential at the inner shell due to charge present on the outer shell, what point should be taken common, that we have to take the distance only where the charge is present. As charge is present on C shell, then you will take the distance C. When the charge is present on shell B, then you will take the distance B. Now we have to calculate potential of B due to charge at A, charge at B, charge at C. This is a point which you have to understand. See, potential of B due to charge at A. So here charge will contribute QA. Now the most important point, 4 pi epsilon naught same. What will be the distance? See, when you have to calculate potential at point B, potential at B, you will not consider distance A, you will consider distance B. At that case, this charge will be contributing to the outer sphere. Inner charge will always reside on the outer surface. So distance will be B. I am repeating this point, as when we have to calculate potential on the outer shell, then inner charge will contribute at the outer distance. This is the very important point. Now substitute the value, QA 4 pi A square into sigma upon 4 pi epsilon naught B. So it will be A square sigma by B epsilon naught. Similarly, potential of B due to charge on itself, this will be given by QB, distance will be itself, that will be B distance. So 4 pi A square minus, it will be because it has negative surface charge density, minus 4 pi A square sigma upon 4 pi epsilon naught B. So it will be minus A square sigma upon B epsilon naught. Similarly, potential of B due to charge on C. See, for the inner shell, distance will be outer one. And for the outer point, for the outer charge, distance will be of outer charge. This point you have to understand. Here, distance will be C. I am taking it again. See here, that if charge present at A and you have to calculate potential at B, so this charge will contribute at the outer surface, so distance will be B. But if charge is present somewhere at this point at C, so this distance, because charge is located at this point, so outer distance will be contributed for the charge present on the outer shell. Inner shell distance will be not contributing, it will be contributing for the point where we are calculating potential. For outer charge, you have to take the distance of the outer shell. So here 4 pi C square sigma upon 4 pi epsilon naught C. So it will be C square sigma by epsilon naught C, it will be C sigma by epsilon naught. So potential at B will be sigma by epsilon naught A square by B minus this should be, let me check at one point, potential of B, this distance should be B square, 4 pi B square, so that's why it will be minus B sigma by epsilon naught. This is a correction here, because for charge at B it is 4 pi B square into sigma, so it will be minus B plus C. Now if you have to calculate potential at C for all the charge, for all the three charges distance will be C. So I am taking potential for C, for it potential of C due to charge at A. It will be given by QA upon 4 pi epsilon naught C. So 4 pi epsilon naught sigma 4 pi A square sigma upon 4 pi epsilon naught C. So it will be A square sigma by C epsilon naught. Then potential of C due to charge at B. So it will be QB upon 4 pi epsilon naught C. So it will be 4 pi B square minus sigma 4 pi epsilon naught C. So it will come out to be minus B square sigma upon C epsilon naught. So similarly calculate potential of C due to charge itself, potential of C itself due to charge present on itself, QC upon 4 pi epsilon naught C. This will be 4 pi C square sigma upon 4 pi epsilon naught C. So it will be C sigma by epsilon naught. Now here potential at C will be, what will be? This will be A square sigma by C epsilon naught minus B square by C sigma epsilon naught plus C sigma by epsilon naught. Taking sigma by epsilon naught common, we will get A square by C minus B square by C plus C. Quite lengthy one, but all the points are important. If you will get one concept clear, definitely you will understand all the points. See, now we have calculated potential at A, B and C. Now, if potential of A and C are equal, then establish relationship between their radii. So what you have to do here, you have to simply compare. See here, I have taken potential of A is sigma by epsilon naught, A minus B plus C. So put this value here, sigma by epsilon naught, A minus B plus C. And potential of C from here, sigma by epsilon naught, A square by C minus B square by C plus C. This will cancel. What will be left? A minus B plus C. This is A square by C minus B square by C plus C. C will also cancel. We are getting A minus B equal to A square minus B square by C. See, this is a simple calculations. When you will do it by yourself, this will give you more clarity. So while attending, just solve it step by step. Now, here, this is A minus B. Let me take C on the left side by cross multiplying. Here apply the formula A minus B, A plus B. So, C is A plus B. This is the relationship between their radii. So one point which you have to understand, that is an important point while solving this numerical, that for the surface we are calculating the potential inner charge if contributing, we will consider the distance of outer one. And when we are considering charge on outer shell, then also the distance of outer shell will contribute. So these are the three numericals we have taken. Just understand it by writing practice. Don't think that we have listened the video and this will give you clarity. Just you have to understand it by writing. So prepare it. Then we will meet in the next class. Thank you. Have a nice day.